Hi students, once again welcome back to our channel VA Academy. Today we will discussing the important bits regarding the units and dimensions. First of all, I am requesting to all of you, you please kindly subscribe, like and share our channel and please try to encourage to us. Then we'll provide more videos of physics, chemistry and biology regarding all competitive exams, especially in SSC and RRB and Group 2 examinations. So today we will discussing about the chapter the units and dimensions. So how the write the dimensional formula. I hope they must be asking the question either SSC and RRB or Group 2. The formulas, dimension formulas, so they're the most important to us. So let us say, suppose if you have to write the dimensional formula, you must be know and consider the mass, time and length. These are the most important. When you have to write the dimensional formula, you must be write mass, length and time. Okay students, so we will start now. For example, what is the dimensional formula of area? Generally, area the formula a square, actually length into breadth, L into L means L into L means L square. So how do we have to write the dimensional formula? So mass is nothing, we are not considered mass is nothing. So L into L square, time is not considered there, so T naughts. So the dimensional formula of area is equal to m naught L square T naught. Okay. Okay students. Okay. The next question, volume. So volume means length, breadth and height. Okay. So L into L. So that is known as the L cube. So what is the dimensional formula? The mass m naught, length L cube, time T naught. Okay. So the next question, density. Density means mass by volume. Mass by volume. We know that one mass by volume, the mass m, volume L cube. So that is the dimensional formula m naught L inverse, because volume in the denominator, when you have to change the numerator -3. So m naught L 3 T naught kgs per meter cube. The next question, speed or velocity. The speed or velocity is equal to distance or displacement by time. So we know that one displacement by time, displacement L by T. So L by T means the L is the length and T is inverse. Denominator we have to change the numerator, that minus value. So m naught L1 T inverse. The next question, linear momentum, mass into velocity. We know the mass m. Okay, mass into velocity. Velocity we know already is one. We were discussing about here L into T inverse. So the dimensional formula m naught L1 T inverse. So kgs meters per second. The next question, acceleration. Acceleration means we know that one now the change of velocity. Okay, time taken, change of velocity by time taken. So the change of velocity L into T by T. So T by T is the denominator, we have to change the numerator LT inverse 2 minus 2. So m naught L1 T minus 2 meters per second square. That is the difference between the velocity and the acceleration. Velocity means meters per second. Here velocity means meters per second square. The next question, force. Force m into mass into acceleration. We know that mass m. Acceleration we already know LT inverse square minus 2. So the value m1 L1 T inverse 2. That the newtons. The force, the K formula, and the units of force is the newtons. Next, impulse. Impulse means force into time. So we know that one mass m and force L into T inverse 2 into T. So the dimensional formula m1, so cancel T inverse 1 and T1 is cancelled. So the dimensional formula m1 L1 T inverse. Newton's seconds. That's the most important bit for us. The next question, pressure. Pressure means the force acting in unit area. That is the formula of the force by area, means the forcing acting per unit area is known as a pressure. So that the units pressure is the Pascal. So we will see that one. So mlt inverse 2 by L square. So the dimension formula m1 L inverse and do T minus 2. Next one, the specific gravity. This is the most important bit. The specific gravity is equal to density of the body by density of the water at 4 degrees centigrade. So m by L cube by m by L cube 1. So that is the one. So m naught, L naught, T naught. There is no units. They don't have any units. Specific gravity, they are asking question for answer. Which one is does not have the units, means the specific gravity does not any units. So then only that formula m naught, L naught, T naught. Okay. So some of the small formulas, these are, you must be remember these formulas. These are the most important formulas for us. Okay, let us see. So work means force into distance. Work means how much work is done in that distance is traveled. So that is the force into distance units, joules. Work done by a body. Next one, energy. Energy means the capacity of doing work. These are also the units, joules. In which one, sometimes there are a question to us, in which one both are have same units, means that is the work and energy, the both are having the same units, joules. The next question, the movement of force. Movement of force means force into distance. That is the force in distance. Okay. Next, power. The power means the rate of doing work unit time. So power is equal to work by time. So the units are watts. Thrust. Thrust means force, that is equal to newtons. Tensile strength. Tensile strength is equal to force and newtons. Newtons, the value is in newtons. We will consider the units of the newtons. Resistance R. Potential difference. So therefore current is equal to mlt inverse 2 into ampere inverse. So the dimensional formula m1 L square T minus 2 inverse square A minus 2 square. That is the units, the resistance of the units, the Ohm's law. Ohms. According to Ohm's law, at a temperature is kept constant, the potential difference between a conductor is directly proportional to the current I. It means potential difference is directly proportional to the current I, where we have to remove the potential, the dimensional formula. So this is the dimensional formula. When we have to consider the V is directionally proportional to A, we have to remove the A dimensional formula. That means we have to remove the directly proportionality. V is equal to IA. So IA means this is the main important Ohm's law. R, resistance. The directional formula is the m1 L square T minus 2 A minus 2 inverse. The Ohm's law is V is directly proportional to I, or V is equal to IR, where R is the resistance of the conductor. The resistance of the conductor R is directly proportional to the length and inversely proportional to the area of cross section of the wire. Next one, angular velocity, angle by time, 1 by t. So T inverse m naught L naught T inverse the radians seconds. Angular acceleration, change in angular velocity by time taken, L by t. So T inverse m naught L naught T inverse radian by second square. Angular momentum, mass into length, L square, m into L square T inverse, kgs meter square second squares. Torque, m L square T inverse square, that is the dimensional formula, m1 L square T inverse square. Newton's meters formula, that is the units of the Newton's meter. Wavelength, length of one wave by one wave distance, L is equal to m naught L1 T naught. Frequency, the number of vibrations per second is the frequency. The number of waves are travels in a particular unit time at that point, that is known as the frequency. The units of frequency is the hertz. 1 by t is equal to t inverse, though it means m naught L naught T inverse seconds. The units are the hertz. Universal gravitation constant G value, so that is the 6.67408 into 10 to the power of minus 11 newtons meter square kg square. These are most important also. According to Newton's universal gravitational constant, the attraction force or repulsion force is the product of the two masses is directly proportional to the product of the two masses and inversely proportional to the square of the distance between them. So you have to remove the directly proportional. So force F is equal to G into m1 m2 by r square. The next question, which one is the not a unit of time? That is the light year. Light year means the units in between the distance between the sun and earth. That is the astronomical units. The accurate measurement of the time by using which one is the give the accurate time means that is the atomic clock only can provide and explain to us to the accurate time we can calculate, that is the atomic clock. 1 angstrom is equal to 10 to the power of minus 10 meters or 10 to the power of minus 8 centimeters. This is the most important bit also. The example of fundamental quantities. The quantities are two types. We are already discussing about that one. These are two types. One is the fundamental quantity and another one is the derived quantity. The fundamental quantity is known as the quantity does not depend on others. This is the independent quantity. For example, length, mass and time. It never depends on others. The second one is the derived quantity. The derived quantity depends on the fundamental quantity. Okay. Next one, the atomic clock is made up of Celsius, 130, atomic number is 133. The units of sound, decibel. One bell is equal to 1 by 10 decibels. The distance calculated is the per second. Next one, solid angle, steradian. The units is steradian. Okay. Next one, energy, kilowatts per hour, HP. Which system is used to mostly in the world? MKS system and SI system. The next question, the quantity having the same units in all systems of the units is that is the time, because we have the three systems, CGS system, MK system and FI system. CGS system is centigrade meters per second. So MK system meters, MK meters kilograms seconds. FS foot pound seconds. But among all these three, The time is constant, seconds. This time is a constant. Webb's meter, next question. Webb's meter square is equal to 10 to the power of 4 Gauss. The example of scalar quantity. The quantities are two types. One is the scalar quantity, one other one is the vector quantity. Scalar quantity means it can be expressed only magnitude, there is no direction. Vector quantity means the vector quantity have both magnitude as well as direction. So the example of scalar quantity: volume, distance, speed, energy, mass and time. This is also important bit. Next one. The example of vector quantity. Vector quantity means we are already discussing. The vector quantity means it can express both magnitude and as well as direction. So the acceleration, the example: acceleration, displacement, momentum, force, velocity, weight and electric current. These also most important bit. Frequently they are asking the question. Next one. A athletic runs before long jump to get advantage on inertia of the motion. The next question. The SI units of momentum is kgs per meters inverse. And CGS units of momentum is gram centimeters per seconds. And the ratio is 1000 into 100 that grams meters per second, 1 is to 10. This is also important bit. Sometimes they are asking the question also.